Good afternoon, everyone. Okay, seems like everyone had a lunch. Okay, let's do one thing. Why don't you guys just raise your hand like this? Just raise it. Yeah, that's fine. Just a little bit more. Yeah. Feels good, right, when the blood flows through? Yeah? Great. Okay. So I would like to start the session by thanking you all taking out your time. Time is a valuable asset, especially when we are dealing with threats. We are always in constant battle, improving mean time to response, remediation. But what if we can improve security teams' burnout time by taking more proactive steps? So today we'll be discussing about that. My name is Tejas. I'm a security specialist, solution architect, and along with me, very well-known name in the cybersecurity community, Himanshu will be joining you. Want to introduce yourself?
Hello, good afternoon everyone. My name is Himanshu. I'm a Chief Information Security Officer at RED and a founding team member. Over to you.
Thanks, Himanshu. So we'll be diving deep today on how we can achieve an actionable impact using a threat modeling. We'll be diving deep into some of the risk management techniques, pros and cons of that, and then Himanshu will help us walk us through how they have modernized their security operations, adopted culture of security, and scaled the threat modeling using generative AI. It's a really cool demo that Himanshu has. I'm really looking forward to see that. So before we dive deep, let's clear some of the nuance around threat modeling. So as a centralized security team, we invest heavily on various different security controls. First-party code vulnerability, SAST, DAST, third-party code vulnerability scanning, like software composition analysis, then we have SBOM scanning. Then we also have the posture management scannings as well, like at the cloud, at the OS, at the application level. But still, when we read those findings, even though it has those severity level, we cannot identify the risk level because at the business risk appetite is different. So we have to correlate a threat, and the threats for every business is different. You might be correlating with the insider threat or an external one. And the risk quantification will differ, the type of a threat that you are comparing. You also have to respond to the threat accordingly because some of the threat intent and the impact will be also differing with each other. So usually as a security team, what we do, we identify all the attack surface that we get it from various different security scanners or the VAPT reports. And then from our knowledge base, from the business risk appetite, we create a threat scenarios. We identify whether someone can do east-west traffic, lateral movement, someone can do an initial exploit or do a CNC communication. Let's look at an example. So here we have an application. It's an application where you upload a S3 file into S3 bucket. It needs S3 access. So what we are going to do is we'll be exploiting this application. There is one more microservice running along with it. Both are running on EC2 in a container, self-managed EC2 instance. And as a threat actor or as a red team, we identified this attack surface. We created the exploit. Now this is the exploit payload, which will do the remote code execution attack. We are adding the CLI and we are sending it as a content type header. HTTP has a multiple headers. We are sending it as a content type header, as a normal HTTPS request. So when we run this Python script with the parameters of the target and the CLI we want to execute, we get an access. So now we have an initial patient 0 we have access to. The next thing we identify what permissions do we have. The container is having the additional permission for creating the Lambda function. So now we created a malicious Lambda function, which will download a malicious payload, a CNC communication, and do a lateral movement between two containers. So now the second container was having secrets in the code. That's how a threat actor is able to go to the database and exfiltrate the data. The reason why a threat actor is able to do this, because there are series of various different attack surfaces are correlating with each other. If you even disable one of them, threat actor is not able to execute their entire kill chain. So for example, the vulnerabilities in the Apache common libraries, or the privileges additional, which was allowing a threat actor to create a Lambda function, or the IAM role attached to the should be attached to the container instead of the node itself. And some of the posture management side, for example, container should have the read-only file system, or it should have hardened credential. Now, these details you identify from AWS incident response services like Inspector, Security Hub, Access Analyzer. But how can we identify the risk before even the risk materialized, before even it goes to the production? That's where the threat modeling helps. So there are various different threat modeling frameworks like Stride, Pasta, Attack Tree, Dread. For example, Stride helps us quantify the risk and apply the mitigation control against application functionality, whereas a Dread helps us quantify the risk, provide the numbering mechanism against the threat, and in each provide the same goal, to quantify the risk and help us mitigate the risk. So usually what we do, we identify various controls that we have. We identify what are the gaps today we have, not just technical gaps, but also operational, people and process as well. And then think of the scenario. These are the predictive scenario based on our experience as analyst experience. And if the scenario, like we have seen in the demo, if it's bypassing all the vulnerabilities, we give the higher score, in this case of Dread. And what do we do about it? So if the score is higher, we usually try to first mitigate as much as possible. So for example, patch the vulnerability, right? Or make sure that root file system is read-only, so no one downloads and run any arbitrary code over there. And then add additional layer of protection, like add AWS WAF for the north-south traffic protection. Make sure that you have deep packet inspection in network firewall, right, for the outbound protection where a threat actor was downloading those malicious payload in the container. Now, no matter whether it's a preventive control, protective, detection response, imagine that you have to do this for every application, all the microservices, and the functionality mapped to it. You have to predict such scenarios, identify those gaps according to your business risk appetite, and then identify the real 5 or 10 things that your team need to be doing it today. Now, we really need to scale this operation, and that's where I would like to invite Himanshu over here to take us through how they have developed an application using a generative AI to do a threat modeling. Yep. Over.
Thank you, Tejas. Cool. So I'll quickly talk about what my company does. So if we think about India, India has a population problem. There are 1.4 billion people in India. Now solving for each of them is nearly impossible. You can't build a product that caters to all the population of India. So what we have done at Cred is we are focusing on top 5%, which is close to 60 to 70 million people, where these are the set of people who have credit score, who have some level of finance, who have money to spend, who have money to invest. So we are trying to sort of build a creditworthy and trustworthy community using our company. We are currently one of the largest fintech based out of India, and we have around 15 million monthly transacting users in our platform. Going ahead, when we think about threat model, as Tejas spoke about, there are a lot of challenges at a scale, and we are trying to solve for threat modeling at a scale. Now, what are these challenges? When you think about threat modeling, it comes much early, even before you have built your product. Largely, it comes during the design phase, where things are very ambiguous. You are not aware about what needs to be solved. How do you really think about threat modeling as such? So what you need to think about is basically, when you think about threat modeling from a product point of view, there are a lot of people involved, right? There are technology people involved, there are product people involved, there are legal involved, there are multiple teams involved, right? So bringing everyone to a single platform is one of the challenges. Second is around the skill gap challenge, right? So not everyone understands threat. Now making everyone understand threat, impact, risk is one of the other challenges where not everyone would be able to visualize or understand the impact on what really threat means in the context of the discussion being done or the product being developed, right? And the attack surface are significantly growing every day. We don't know what we are dealing with, right? And if you think about threat modeling, I think there are a lot of frameworks. Now, each of frameworks give you a different kind of results. And it's very difficult to consolidate all of these results into a single dashboard or a single framework. And that's what we are doing. We have built Threat Shield. It's an AI-powered threat modeling platform. It's an in-house platform right now. So what it does is basically it helps you predict all sort of threat modeling much before the developer has started to build a product, or even the product people are still in a hypothesis phase, or even the legal team is sort of looking at what could be the risk from launching a 0-1 product, right? Second is obviously for our engineering people. The challenges are again very vague. Much before the code has been written, developers don't know what really to focus on. And again, for security people, it's very challenging to say or convince engineering team on what really needs to be focused on, right? So challenges are very, very diverse, and it's very difficult to cater to all set of audience. And hence, this Threat Shield actually helps cater to all the audience that is possibly looking at a 0-1 product or a growth product, right? And again, like if you think about threat as such, there is obviously risk, impact, severity. There are a bunch of jargons. And it's nearly impossible to explain all the technology and non-tech folk about the security risk that could arise from launching a product, right? So Threat Shield actually gives a consolidated view about all the risk or all the severity in the product that is being developed. And last but not least is around the validation. Once you have identified all of the threats, how do you really validate? How do you basically prioritize things? Or how do you say that these are the things that you really need to focus on and fix, right? So Threat Shield actually helps you do all of these. Now thinking about impact, so once we have built this product and once we have moved into production, what we have understood right now, the impact is huge. And again, like when you think about impact, we have developed this and we have rolled out to 40 plus services. These are all microservices hosted on AWS. And we have seen around 30% reduction in time to basically do the threat modeling across these 40 plus services, right? So again, looking at the second metric, there are 30% faster review times. Earlier, we used to spend a lot of times in doing a lot of to and fro with product people, explaining them what we really need, and they explaining us how we need to think about the entire customer journey. So this time has reduced. There has been a significant reduce of around 25% on security findings, because what really happens is using Threat Shield, we are able to predict what can go wrong much before the product is being developed. And last but not least, all the engineering team can confidently ship their product or their code into the production by using Threat Shield, right? So now talking about the architecture, I have put a very simple architecture here. Now all of these is powered on AWS. Going from right side, extreme right, we have like a underlying large language models. It could be Claude, it could be DeepSeek, or anything that is supported by AWS Bedrock. So Threat Shield is basically powered entirely by AWS Bedrock. And this is a power like we don't have to really go out of the cloud to scale or build anything out, right? And on top of it, we have used open source light LLM. This is mostly for governance layer and role-based access control. And that's where Threat Shield is, on the extreme left, where everything is built on top of AWS Bedrock and light LLM underlying using Claude and DeepSeek. I have a demo here. Once the demo is done, I'll be standing outside. Maybe we can talk more. I'll go ahead and play the demo. So I'll walk you through the demo here. So what you do is you start your assessment. Here you enter any of I've just taken a dummy project name here. So you talk about a project, what your project is about. You upload a PRD. PRD is your product review document. So once you upload your PRD, you can give more context. It could be a Confluence doc, it could be a Slack thread, or you can also upload your architecture diagram. Once you have done this, you can give basic details about what you're really going to do an assessment about, right? What type of application is being developed, and what sort of authentication mechanism you are using. So after feeding all this basic information, Threat Shield in the back runs bunch of racks, does all sort of automations, gets full context of your PRD, parses it, and then based on that, it generates your entire threat model and attack surface. using AI. So once you look at all this, once the threat model has been, attack tree has been generated, you will have a complete DREAD score, which Tejas earlier spoke about. And then once the score is developed, you will have all the mitigation that ThreatShield can provide you. So over here, if you see, this is a result of a simple PRD. You can think about this from a stride perspective. These are all the results for stride. So you can look at and you can focus on what really are the problems with the PRD that was developed or that was uploaded to ThreatShield. And you can go through each of them. These are like plain English. You don't need to really be a hardcore technical person, and anyone can go and understand what really is, what is the impact, what is the risk, and what really needs to be focused. Next, you have attack tree. Here, based on whatever threats had been identified, you can generate, or the AI will generate attack trees, and based on that, you can go look at the attack tree and basically focus on specific things that you really need to prioritize. Right? So here, again, like you will see a basic understanding of what the attack tree is. After that, we give a DREAD score. Here, in context of DREAD score, basically whatever was identified, we score all of them so that it's easy for us to prioritize what really needs to be looked upon even before the product has gone live. Right? So all sort of issues. On the extreme right, you will see all sort of scores, and then you will see a risk distribution across all sort of identified issues. Right? And last, you have mitigation. Once the issue has been identified, a score has been given, how do you really mitigate? I mean, these are the mitigation steps which developer or tech team can basically go, understand, read through it, and basically apply best practices or apply all the mitigation strategies. Once you go back, you have all the historic report. Whenever you do basically an assessment, you will have a historic report of whatever the PRD was uploaded or whatever the assessment was done. Here you will see a clear view of entire report in a single pane, where you will have a historic identification or understanding of what really had gone wrong in the product, and there is a complete audit log of what has gone wrong in previously and what has been fixed and how things can. Right? So this is not point in time. This can always be ongoing, like Tejas said earlier. Right? And you can generate a report, and this report can be shared with your auditors. It can be shared with your product team. It can be shared with your legal team. Even if you are doing like a third-party assessment, maybe you can use this report to share with your third-party supply chain. And here we are giving a like a AI assistant where you can, if you don't want to look into the report, you can directly query here in context of the report. For example, what are the top 3 hits, and then you will get to understand all the issues that were identified. And this is like a final dashboard where you will have the entire overview of your entire organization threat modeling that has been conducted on the ThreatShield platform. So this is the demo. ThreatShield is coming soon. We are in the last stage of sort of releasing this product. So expect it to go live. It will be an open source product. Again, like I said, built on top of AWS. But for now, if you want to play around, we have Threat Composer and threat modeling using AWS Bedrock. These are again open source product on AWS GitHub links. You can scan the QR code, and then possibly once we go live with ThreatShield, we'll make some announcement on LinkedIn or social media. That's all from our side.
Yeah, thanks.
Over to you.
Thanks, Himanshu. That was really great demo. So if you guys have any feedback, you wanted to talk to us, understand. If you want to build something like that, feel free to hold us over here. We will be here nearby. But yeah, please give us the feedback if you feel this is good or any additional details that you need. Thank you.
I do have my head of infrastructure and AI labs standing there in the corner.
Yeah.
Maybe feel free to speak with him. He's waving hand there. So will you downstairs? You can connect with us post this session. Thank you so much.
Thank you.
Highly appreciate.